In this video, we will talk about specialized maintenance and troubleshooting tools. There are three types of troubleshoot tool categories. The first one is information collection tools. Such tools have the ability to analyze and improve the network performance or security. Tools that continuously collect of information to establish a baseline are the tools that statistically transform data by pulling data from network devices with SNMP and NetFlow. These tools have information on how the network's natural behavior is due to its key performance indicators on the network and constant data gathering. The tools in the category of notification of network events are the tools which use syslog messages or SNMP to inform the administrator about the network failures and etc. Let's continue with traffic capturing tools. For example, Wireshark, guys, that is a network packet analyzer. A network packet analyzer will try to capture network packets and tries to display that packet data as detailed as possible. You can think of a network packet analyzer as a measuring device used to examine what is going on inside a network cable, just like a voltmeter is used by an electrician to examine what is going on inside an electric cable, but at a higher level, of course. So in the past, such tools were either very expensive, proprietary, or both. However, with the advent of Wireshark, all that has changed. Let me give you some examples people use Wireshark for. For example, network administrators use it to troubleshoot network problems. Network security engineers use it to examine security problems. Developers use it to debug protocol implementations, and people use it to learn network protocol internals as well. Another useful troubleshooting tool is SPAN, Switch Port Analyzer, or port mirroring. That is an efficient high-performance traffic monitoring system. It directs or mirrors the traffic from a source port or VLAN to a destination port. SPAN is used for troubleshooting connectivity issues and calculating network utilization and performance, among many others. SNMP, Simple Network Management Protocol, that is an Internet Standard Protocol for collecting and organizing information about managed devices on IP networks and for modifying that information to change the device behavior. So devices that typically support SNMP include the routers, switches, servers, workstation, even printers and more. So SNMP is widely used in network management for network monitoring, and SNMP exposes management data in the form of variables on the managed systems organized in Management Information Base (MIB), which describe the system status and the configuration. So these variables can then be remotely queried by managing applications. The SNMP process involves several key steps, guys. So SNMP agents installed on network devices such as routers, switches, servers collect and store management information about device operations and performance metrics. Then agents maintain a database called MIB, which organizes and stores the collected data in a structured format. Then SNMP managers, they are the network management systems or softwares, send requests to agents to retrieve specific information from the MIB using protocols like SNMP GET, GetNext, GetBulk, SET, and others. Then agents send unsolicited notifications called SNMP traps to managers to inform them of significant events or conditions such as device failures or performance thresholds being exceeded. For security purpose, SNMP utilizes community strings for authentication to control access to managed devices, ensuring only authorized management stations can retrieve or modify information. So overall, SNMP facilitates proactive monitoring, management, and troubleshooting of network devices by providing a standardized framework for collecting and exchanging management information across diverse network environments. Here are three main versions of SNMP. SNMP version 1, 2, and 3. Version 1 is the original version, simple and widely supported but lacks security features like encryption. Version 2 introduced some improvements over version 1, including enhanced protocol operations and support for community-based security. And the version 3 is the most secure version, offers encryption, authentication, and access control features suitable for handling sensitive network management tasks. The SNMP community string, guys, that is like a password that grants access to SNMP managed devices. It serves as a basic form of authentication and allows SNMP managers to retrieve or modify information on network devices. And SNMP community string is used in SNMP version 1 and SNMP version 2. SNMP community strings come in two types, read-only and read-write. Read-only allows SNMP managers to read information from the SNMP managed devices, but does not permit them to make any modifications. Read-write allows SNMP managers not only to retrieve information, but also to modify, write the configuration settings on SNMP managed devices. And let's continue with NetFlow. NetFlow is a network protocol developed by Cisco that allows network administrators to collect IP traffic information as it enters or exits an interface of a router or switch, guys. So NetFlow is used for network traffic monitoring, analysis, and troubleshooting. So NetFlow-enabled devices generate NetFlow records containing information about each packet flowing through the device, and information typically includes source and destination IP addresses, ports, protocols, byte counts, timestamps, and etc. And these records are sent to a NetFlow collector for storage and analysis. So NetFlow helps in identifying top talkers and bandwidth usage patterns, facilitates network traffic accounting and billing, and also assists in detecting and mitigating network anomalies and security incidents. So the benefits of NetFlow, first of all, it provides visibility into network traffic behavior and performance. Secondly, it enables proactive network monitoring and capacity planning. And third, supports efficient troubleshooting by identifying network bottlenecks and anomalies. Let's continue with the syslog. Syslog is a standard protocol used to send log messages and event notifications over an IP network. So it allows devices, applications, and systems to generate and transmit log messages to a central syslog server or collector. So devices such as routers, switches, servers generate syslog messages containing information about events, errors, warnings, or status updates, and these messages are formatted according to the syslog protocol and sent to a syslog server using UDP or TCP on port 514 by default. The syslog message format consists of a header and a message body. The header contains metadata such as the timestamp of the event, severity level, facility code, and the hostname IP address of the device generating the message, as you are seeing on the screen. and the message body contains the actual content of the log message, which includes details about the event, error codes, and additional information relevant to the logged event. So for this example, the message body is interface fast Ethernet 01, change state to down. Okay, so together the header and the message body provides essential information for monitoring, troubleshooting, and managing network and system events centrally using syslog servers. A syslog server is a centralized system that collects and stores log messages from various network devices and applications for monitoring, analysis, and troubleshooting purposes. So what you are doing basically, for example, in a Cisco router or switch, you define a syslog server. All the logs generated by these servers, switches, routers will be forwarded to a central syslog server as a central log repository. And lastly, we will talk about EEM, Embedded Event Manager. That is a Cisco iOS feature that allows network administrators to automate network operations and respond to specific events on Cisco devices. EEM can execute scripts or commands based on predefined conditions and events, enhancing automation and proactive management. So EEM can react to various triggers, including the system events, CLI commands, and interface status changes. So common triggers include syslog, SNMP thresholds, and the timers. Upon detecting an event, EEM can execute a range of actions such as running commands, sending notifications, or invoking scripts, and supports complex logic and conditional execution as well. There are two types of EEM policies, and they are applets and the policies. Applets are small scripts that run directly on the device. On the other hand, policies are more complex and structured scripts allowing for detailed automation and response.